Okay, so we are finding the average rate of change today. Today's going to feel like 95% of the year. Since we've done this before in the past few weeks, everyone should listen to this or practice on what we can use to see how it's going. We are finding the average rate of change. The average rate of change is just how the lines are. So if I just put points on the graph and another point on the graph, I may actually find this slope in them. So average rate of change will be slope. Now if you're talking about a line, doesn't matter if I choose those 2 points, or these 2 points, or these 2 points, the slope will be the same because it's a line. But if I talk about something that curves, not normal. There we go. There we go. If I find something that curves, so like the slope between these 2 points is different than the slope between those 2 points because of the curve. And it would be different than the slope between those 2 points, and that's different than the slope between those 2 points. So as you have a curved figure, the average rate of change is not the same throughout the course of that figure. Now, before we move on, let's remind ourselves how to find the slope. The slope is the change in your y over the change in your x. There's actually a symbol that represents change. One of the slides in the class what it is. You know what it is? Oh, I don't know. I don't really tell you to teach you that for the first time, but maybe you already know that. And there's a formula that goes with it. The symbol is M. M stands for probability of the radicals and plus b. So M equals y2 minus y1 over x2 minus x. So we're just going to start by practicing finding the slope between those 2 points, just to make sure you remember how. And then we'll look at how to do the slope on the graph. And then we'll look at how to do it in class. Okay, so how do I find the slope between points 1, 2, and negative 3, 4? What do x2, y1, x2, y2, y1 stand for? It's talking about the second y point, the first y point. So when I label this, x and y1, it stands for the x value on the first point, the y value on the first point. So this is the x value on your second point, the y value on your second point. And it doesn't matter which one's point 1 and which one's point 2, as long as the ones are together and the twos are together. So when you plug in and find the slope, it equals y2 minus y2, which is 4, minus y1, which is 2, over x2 minus x1, 4 minus 2 is 2, over negative 4. So what would the slope be between those 2 points? We just got into a negative. Okay. Now that doesn't tell me the shape of that graph. I just know that the points are 1, 2, negative 3, 4, and the graph could look all sorts of, this is kind of this. We don't know. We just know that the slope between those 2 points is a negative 1. Find the slope of the line on the graph alone. But because it's a line, it doesn't matter what interval we use. We just pick 2 points. If you're looking at a graph, I always like to start on the far left, so up and down first. So this is x2 over 1. So my slope would be 2 over 1, which would just be so that's an example of how you find the slope given these 2 points. This is an example of how you find the slope given a graph. And again, there's special circumstances for average rate of change when you're talking about a straight line because they're linear. The average rate of change is constant, meaning that there's no curve. So it doesn't matter again what point you choose, the average rate of change will be the same always. But if it's not linear, like it's quadratic, you're not going to have a constant average rate of change because it's different depending on what 2 points you pick. There's another way to write the algebraic function. You have the formula right there on the top. And again, it's written down there on the bottom. If I wanted to write it as a function or a system, this is what it would look like. This is given on the interval AB. So usually what's going to happen is they're going to give you two x values. This will be x1 and this will be x2. And you plug them in to find the y value. So this is my function at B. I plugged B in. This is my function at A. I plugged A in and I got something over B. It's a really fancy way of just saying this. I don't know that it's necessary to know that, but maybe to look at it. It's fancy. So let's try a few of what your homework's going to look like tonight. The first thing I have is consider the following f of x equals 2x squared. Graph the function and use the graph to find an arbitrary point over the interval at 0, 2. So this is talking about x1 and x2. It's giving you an interval of where to find the arbitrary point. Let's start by graphing it. What shape is this graph? The parabola. Where's the vertex of the parabola? 0, 0, good. And the stretch normally the parabola is divided over 2 upwards. So we're going to take all of our ups and multiply them by 8. So over 1 up 2, over 2 up 8. Oh, wow, we're doing it pretty quick. So graphically, if I wanted to find this average rate between 0 and 2, it's talking about this interval to this interval. So what x values, what y values are there? So I'm starting right here. This is my y value. How do I get from point to point? I go plus 8 over 2. So my slope would be 8 over 2, which is 4. Yep. Now, algebraically, this is what it would look like. When f is 0, what is y equal? 0. When my function is at 2, my y value is at 3. So the very first thing I would do is I would evaluate the function at 0 and 2, which is 2 points. Again, this first one becomes the x value here. The second one becomes the x value here. And then once I do that, I'm going to use first order pairs to find the slope. So n equals, we should get the same thing as here, because we're just doing it as a solve. M equals y2, because it's necessary for you to label them as 1. y2 minus y1 over x2 minus x1, 8 over 2, which is 4, not super surprising. So that's pretty much all we're doing today. Let's practice it again using a different, let's use a different interval. There's actually a way that I could get these, if my function is y equals 2x squared. I'm going to do this one by hand, and then we'll do examples for you through a calculator, and you can do it the way you want to do it on your homework. So if I want to figure out the 2 points that I'm looking at, my first x value is going to be 1, and my second x value is 2. Because it says you need a function of x. So using the function of both sides, arbitrary space to the following intervals. So I'm going to use this function. If I want to plug in a negative 1, what would I get? 1 squared is 1, 2 times 4 is 2. If I plug in a 2, I get. So all I'm doing here is I'm using my equation to get an xy over 10. There's a faster way to do it using the calculator, but I'm going to show you just a moment. But now that I have my order pair, I want to find the arbitrary change x1, y1, x2, y2. So my average change is y2 minus y1 over x2 minus x1. Whenever we have that minus and minus, be really careful. That minus needs to become a what? 8 minus 2 is 6 over 3. My average change is 3 and 1/3 by 2. How come that 2 is different than up here? We got 4. How come they're different? Because they're different points on that big line. Good. Let's do that again. What are the points? If I plug in a -3, what do I get? So y equals 2 times -3 squared. 18. If I plug in a +3, I get what? 18 again, right? If I'm finding the slope, 1. y2 minus y1 over x2 minus x1 is 0 divided by 6 equals what? 0. What would that look like on the graph? What does a 0 slope look like on the graph? It's like taking 2 points that are right across from each other. So the line between those would be flat. Which I guess makes sense that you could come up with those would work that way. Yep. And then all of these averages are different because the function is a curved line, not a linear line. Let me show you how to do this on the calculator that makes finding these points a lot faster. Yes? Only situation that could get x over 0 is when x equals 2. Because then that line will not go 0. And the slope is going to be clear and line. That would indicate that you're not talking about an actual function yet, or I mean, it's not often that we see that on the but when you're talking about yeah, I think that you probably will see that before. Yeah, it does. You would say that the slope was undefined. We had, what am I doing here? It's chirping at me now. We had like a line, a little line that was like under the line is undefined. So if there's a 0 under the line, then your slope is undefined. I'm ready. Zoe? For that last problem? It's hard to see because it doesn't fit on this graph. Our graph looks like this, right? 8, like this. Something like that, right? And so it's kind of blurry, but at -3, it was up clear here at 18, and at +3, it was up here at 18. So the slope between those 2 points was a flat line. Yeah. Okay, let's look at this next one. Example 3. I could plug 4 into this equation, and I could plug 8 into this equation, and I could get 2 points. But there's another way to get all of the points that we need very quickly. So go to your calculator. Does anybody have a Casio that I need to worry about? Good, curse the Casio. Yeah. Okay, so up into your y equals, or your y button up here in the corner, I want to plug in the function that I'm using. Again, this function is -2x squared plus 2x. And what I'm going to do is I'm going to not graph it. I could graph it, but I'm going to go to the table. So choose second graph, and you should get to the table. We've used the table before, right? Now, if you don't want to plug this in over and over and over again, you could use the calculator. And if I want to know what's happening when x equals 4, let's just go down to 4. And x is at -24. So I know 4, -24 is my first point. And 8, -112 is my next point.
So after I plugged it into the y equals, I'm going to go second graph. Nope, there's an X button right next to the alpha button. It says XT theta N. There's your variable button. I don't know. I think it's just the X is the catch-all for all of those variables, and T, theta, N are just common variables that we use. I don't know. So then second graph will bring me to the table. So let's see if we can get our other points. When X is at -6, so scroll up. Where's Y? Good, -6, -84 is your next point. 0, huh? It's a parabola, yep. 0, 0 is your next point. Part C, -4. What's your next point? -4 what? -40. And 8, -112. So we can use our calculator to quickly come up with these points rather than plugging them all in. If you don't have a graphing calculator, you're going to need to plug them all in, and it's not pleasant, but I've already showed you how to do that, right? Just plugging them in and get the points. All right, so rather than us all taking forever doing this, why don't we have this first section, Caden's section right here, do part A. Part B, let's go in the middle section, then part C, you the 4 against the wall, small group. And that is lunch. Have a good lunch. We go to lunch. And then over 2 over 3 9 take off the color not anything there or
why are your colors so vibrant?
This is like white on white, right? Really think that they can put a little bit again, I can write it down easily.
Yeah, like yours is like a dark blue.
No, we're going an exponential graph with a variable x point. You should have learned how to graph these last year. And really, you can't graph one time two ones. Where one is your starting spot, and the starting spot is one. Now you don't think that you're going to be exactly on the line. The two is the multiplier. So as I move on to the right, I'm going to square over. I'm going to multiply my y value by 2. So right now my y value is at 1. And the over one spot, I'm going to take that 1, double it, and now I'm at 2. And now I'm at 2, go over 1, and you double that 2, and now I'll be at 4. And I'm going to 1 over, and then double the 4, so I'm at 8. Because this is 1, 4, 9, 16. This is 1, 2, 4, 8, 16. Doubling the y9. This next one will be 25. This next one will be 32. Yeah. Now, as I go to the right, I multiply, which means as I go to the left, I need the opposite, I divide by 2. So if I'm at 1, and I go over a box, I'm going to be 9 times 1. This is 1 half. And then half of that half is 1/4, and half of the fourth is 1/8, and then 1/16, and 1/32. Will I ever get to 0? I get really close to 0, but I stay back in the 0. So my exponential function is something like Okay, so what we're going to do now is we're going to find an average rate of change in different intervals on these two equations. So looking at the graph level, I want to find average rate of change for -1, 0. Let's look at the x squared graph. Let's look at the 2d x graph. So from -1 to 0 right here, it's this point to this point. What's my slope there? I go down 1 over 1, which would be -1, right? On the exponential graph, at -1 in here, at 0 here, so from point to point, I go up how much? I go up 1/2 over 1, which would be 0.5. So which one has a greater average rate of change on that interval? The -1 is cheaper, right? So x squared has a greater average rate of change because 1 is bigger than half. Let's choose a different interval. Let's say from 0 to 2. So from 0 to 2, I go up how many over how many? Up 4 over 2, right? So the x squared graph is 2. So the x squared graph is going to go up 4 over 2, which is going to be a slope of what? 2. So 2 to the x at 0, I'm up here at 1. At 2, I'm up here at 4. What's my time here? Up 3 over 2. Which one has a greater average rate of change in that interval? The x squared or the 2 to the x? The x squared. So we're just finding the slope between those 2 points and saying which one's greater. Now, depending on the interval, depends on which one's greater. So on this interval from -1 to +1, -1 in here, +1 in here, what's my change in y between those 2 points? Change in y is 0. Over, I go right 2. 0 over 2 is 0. What about the 2 dx? From -1 here, +1 in here. And then go up 1 over 2. Is that okay? Now, I don't know what that is, but I do know it's bigger than 0, right? So which one's greater, the x squared or the 2 dx? In that interval. The exponential 2 dx. So depending on the interval, it depends on which one has a greater average rate. Okay? Any questions with average rate of change? You can find it out in the first whatever. You okay? Okay, let's move on. We're almost done. So if you are something on your phone, take away a little bit. Wow, we're doing that. Let's go on to these two. These ones are, there's two ways to look at these problems. The first is on the calculator. So go ahead and get your calculator out. If you don't have a calculator, you're going to have to do this by hand, and I'll show you how to do it by hand as well. So we'll do A and C using the calculator. We'll do B and D by hand. The first thing, for example A, I need to plug both of those functions into the calculator, but you need to know where to find the absolute value graph on the calculator. Give me 1 second. Let me see if I can get this darker so you can see it a little bit. There we go. So if you go to the math button right here underneath the alpha button and scroll over to number, that very first one, ABS, abs, stands for absolute value. So if you push enter, you should get either it saying ABS with a parenthesis, or you should see actual absolute value marks. So I'm going to type in
x plus 2, again, the variable button is right next to alpha button. It says xt theta n. X plus 2 5. But it doesn't have the what part? So you put parenthesis x plus 2 parenthesis, close it off, plus 5. So I'm going to graph that. Make sure yours looks like mine. I'm going to walk around and make sure you got it. Anybody else need help doing that? Somebody read it for me. Which graph has the highest y-intercept? So let's go back into the y-equals and graph both of our functions in the same graph. And then I'm going to make a little note for you. Who is not using your graphing calculator really quick? Is everybody on a graphing calculator? Alan, you don't have one? Anybody else not have one? Okay, so let me show you how to do this without a graphing calculator. But let's graph these. We're looking for which one has the higher y-intercept, so you just compare them. Is the absolute value or is the parabola have the higher y-intercept? Looks like it was the absolute value, right? So the absolute value is your f function. So I'm going to say my f of x function has the higher y-intercept. Really, yeah, I don't care. Really quick, how do I do that without a calculator? If I'm looking for a y-intercept, that means x equals 0. So without a calculator, I would plug in 0. The absolute value of 0 plus 2 is 2, and 2 plus 5 equals 7. Plug in a 0 here. 0 minus 2 is a negative 2. Negative 2 squared is 4. Which one's bigger, 7 or 4? 7, so the f function's bigger. Okay, part B. I've already done this problem, but I'm going to post it note cover it up. On part B, let's do this one by hand just to remind you how. So the question is, which function has the lowest minimum value? If it's talking about a minimum value, what is it referring to? It's asking about the y part of the vertex, right? It's talking about the minimum value. That means I need, if I have my calculator, I could just plug them into my calculator and do it. Without the calculator, though, how do I find a vertex? X equals negative b, which in this case would be negative 6, over 2a. But I don't care about the x part of my vertex, I care about the y part of my vertex, right? So how do I find the y part of my vertex? So -3 squared plus 6 times -3 plus 3. I get -6 twice apparently. So there's my vertex for the F graph. Let's look at the G graph now. X equals -b, so a -2 over 2a, which would be 1. If I'm plugging 1 into my function, so 1 squared minus 2 times 1 plus 12 would give me an 11. And go back and read the question. Which of the functions has the lowest minimum value? Which one has the lowest minimum value? Which one's smaller, -6 or 11? Okay, so f of x has the lowest minimum value. So let's look at the calculator really quick. So clear that out, clear that out. X squared plus 6x plus 3. Just check your functions really quick. Make sure they're the same thing as what they're supposed to be. Not for part B. So clear it out, yep. And then graph those. Let's just make sure the one's coming down here. The other one you can't even see because it's too high. Yeah, the other one you don't even see. So if you change your window so you can see a little bit higher. There's one function. And the other one is right there. So which one has the lower? The f function does. Yeah. Okay, let's look at part C. We're going to do this one on the calculator again. So, which function has the highest? There's actually a typo here. It's supposed to be minimum value. Both of these open up, so it needs to be a minimum value. Again, if it's looking for a minimum value, you're looking for the y part of the vertex. By hand, I lied, we'll do this by hand first. By hand, this one right here, the vertex is going to be at 0, -2, because you take the opposite of what's in here, and then -2. To find the vertex on this one, again, you're going to do x equals -b over 2a, and plug everything in. So let's use a calculator, see which one that is. So do you remember how to get the absolute values? What do? Math, number, absolute value, unless yours is special. 7 is yours, okay, going to the catalog, got it. Okay, and then x minus 2. Jay's yours is also different, right? Are you okay with it? Okay. Minus 2. Okay, plug those both into your calculator. Let's graph them. There's my first function. There's my second function. The question says which one has the highest minimum value? Well, the absolute values, minimum value is there at -2. The red one's down here, I don't know where. Which one has the greater minimum value? Your f function. Good, the first one. So the rest of today's lesson, you can barely even see that on my board, sorry. The rest of today's lesson just compares functions. Let's do the last one. So for part D, which has the vertex that is further to the right? If I'm asking about a vertex being further to the right, what part of the vertex am I referring to? The x part or the y part? We're looking at the x part of the vertex. My pen's dying. Okay, so what is the vertex on the f function? That -3 tells me that the graph is shifting 3 units where? To the right. So the vertex is 3, and the -1 means it's shifting up or down? Down. Yep, down. The g function darn it, bumps me out. I really like this pen. The g function, if I use the -b over 2a, That would be -3. Do I even care about this part of the vertex? No, because I'm looking for the x part of the vertex. Which one of these vertices is further to the right? The first one, the 3, right? So my f function is further to the right. If you were to graph those, you should see that the one is further to the right. No, it shouldn't be dying. Look how much is left in there. Dang it all. Stupid pen. All right, the rest of the time is yours. Let me pass out your homework. This homework will get you through day 4 and day 3.